Good morning. So we'll start with the actual syllabus of network theory. So the new thing which you will learn here in the first module is dependent sources. First we'll see what is studied in BEE. They were called as independent sources. Why? Because output characteristics are not dependent on current or voltage in an independent source. So you have just two things, a voltage source having some voltage V and a current source having some current I. Voltage V volts, current I amperes. But what are dependent sources? Voltage or current of a source depends in turn upon some other voltage or current in other part of the network. I repeat, voltage or current of a source is depending on some other voltage or current. So what we have? We have two sources, voltage and current, and we have two quantities, voltage and current. So 2 raised to 2 is 4. So you have four type of dependent sources. So first is called as voltage controlled voltage source. What happens here? You have some voltage in other part of the network and you have a source which is a voltage source. So the voltage of this source is controlled by the voltage of some other part of the network. So that's why it is called as voltage controlled voltage source. So if you write the equation VCD is equal to mu VAB. So you observe here voltage of the source is being controlled by some other voltage VAB. That some other voltage is this. Similarly, we have voltage controlled current source. So in this we have a current source. But what is happening? The value of the current source is being controlled by a voltage VAB. So we have ICD, the current of the current source being controlled again by some voltage VAB. Similarly, what happens in current controlled voltage source? We have a voltage source, but the value of the voltage source is controlled by some current which is in other part of the network. So we have VCD equal to RIB. So the value of voltage source is controlled by the current. Similarly, in current controlled current source, the value of current source is controlled by current in some other part of the network, which is this one. So these are the four types of dependent sources. So without further ado, we'll directly jump on numericals. So first part is mesh analysis using dependent sources. So we have already revised mesh analysis, super mesh analysis, node analysis, and super node analysis. So we'll again go through them one by one, but using dependent sources. Okay. So this is the first question. Find the mesh currents in the network shown. So what are mesh currents? The things which we were taking clockwise are called as mesh currents or loop currents. Strictly speaking, mesh currents. So we have to find mesh currents. So what will be the first step to assign mesh currents? So this is, let's say, I1 and this is I2. So what we have to do? We have to find the value of I1 and I2. Okay, so what is the first step? We assign the mesh currents, then we assign the polarities. So this is plus minus. So for this we are moving in the upward direction. So this is plus minus. For voltage source, it is already given plus minus. For a dependent voltage source, I mean, this will be plus minus, this will be plus minus, this will be plus minus. And remember, this is minus plus. So for this, what will it be? This becomes plus minus, this becomes plus minus, this is plus minus, and this is plus minus. So what we'll write? Applying KVL to mesh 1. So let's start from here. So what we get? Minus 5. Minus 5. What is the current flowing? I1. Minus 5 minus 5 I1 minus 2 V2. It is a voltage source, so directly take that value. Minus 4 I1 minus of what will become here? I1 minus I2 plus 2 V1, value of voltage source. Again we write it directly, same way we wrote this value minus 5 directly, equal to 0. So what you observe, ideally we have two meshes, so we have two unknowns, I1 and I2. But what is happening here? We are getting the two unknowns, I1 and I2. But apart from that, we are getting two other unknowns, V1 and V2. What does this suggest? We have to write V1 and V2 in terms of I1 and I2. That is the only extra step we encounter in dependent sources. So our first step in mesh analysis after assigning mesh currents and polarities is to write the dependent quantities. These are called as dependent quantities. So from the figure we write V1 equal to, so what will be V1? So you have to just write it in terms of Ohm's law. What is Ohm's law? V equal to IR. So V1 is 5 into current. 5 is resistance, I is current. So 5 I1. So the question is it positive or negative? So for that, simply see the polarities. This is plus minus, this is plus minus. So they are opposite. So it will be negative. Similarly V2. So for V2 polarities are same, so it will be plus and 2I2. So next step what we have to write, let's say this is equation 1, this is equation 2. Therefore from 1 and 2, minus 5 I1 minus 2 times V2. So 2I2 minus 4 I1 minus I1 plus I2 plus 2 into minus 5 I1 equal to 0. So therefore minus 5 I1 minus 4 I2 minus 4 I1 minus I1 plus I2 minus 10 I1 equal to 0. So just simplify this. So first I am writing I1. So minus 5 minus 4 is minus 9, minus 1 is minus 10, so minus 20 I1. Then I2 minus 4 plus 1 minus 3. So minus 3 I2 equal to, this is minus 5 constant, and that's it. So when it comes to the right side, it becomes plus. So this is equation number 3. So then what we'll do, applying KVL to mesh 2. So let's start from here. So what will we get? Minus 2 V1 minus of I2 minus I1 minus 2 I2. Am I correct? Yes. Minus 10 equal to 0. Right? So again write V1 in terms of I1 and I2. So V1 is what? Minus 5 I1. So therefore minus 2 into minus 5 I1 minus I2 plus I1 minus 2I2 minus 10 equal to 0. So therefore 10 I1 minus I2 plus I1 minus 2I2, I'll take this 10 here. So therefore 11 I1 minus 3 I2 equal to 10. This is equation 4. So I've got the two equations. So solving equations 3 and 4, what will we get? I1 and I2. That's what is the question. Find the mesh currents. Right? So first equation was this, minus 20 minus 3 5, 11 minus 3 10. So we get I1 as 0.1613 ampere. It is positive, so it will be in clockwise direction. I2 is minus 2.71, so I will directly write 2.7419 ampere anti-clockwise direction, because it is negative. Remember, I have written the positive value, right? So this is the way you have to solve sums on dependent sources. So let's take one more example. So now we have current controlled voltage source. So find the currents Ix and Iy of the network shown. So where is Ix and Iy, that we have to determine first. So this is Ix, this is Iy. So what is the first thing? To assign mesh currents I1 and I2. Then assign polarities. This is minus plus, remember. So when you assign from this side, this is plus minus, this is plus minus, this is plus minus, this is plus minus. Right? So what is the first step? We saw in the last sum that we require the dependent quantities, we write them first. So dependent quantity is what? Iy and Ix. So what will be Ix? It is going downwards. So I1 minus I2. Why I1 minus I2? Why not I2 minus I1? Because Ix is going downwards and I1 is also going in the same direction. So Ix equal to I1 minus I2. And Iy will be what? Can I say it is simply I1? Because it is in the same direction. So Iy is I1. Then applying KVL to mesh 1. So this is equation 1. This is equation 2. So minus 5 I1 minus 2 Ix. Remember, it is a voltage source, so this is the value of the voltage. Don't get confused with how will current come in a voltage source, current variable. Then minus 4 I1 minus of I1 minus I2 plus 2 Iy equal to 0. Next, substitute Ix and Iy. So therefore minus 5 I1 minus 2 times I1 minus I2 minus 4 I1 minus I1 plus I2 plus 2 Iy equal to 0. Sorry, Iy is what? I1. So this will become I1. So just calculate this. No need to show this step that this is minus 2I1 plus 2I2. If you are confident, you can directly write the final equation. So collecting the terms in I1, this is I1, this is I1, this is I1, this is I1 and this is I1. So minus 5 minus 2 is minus 7, minus 4 minus 11 minus 12 plus 2 minus 10. So minus 10 I1. Then collect the terms in I2. This is plus 2 plus 1. So 3. So plus 3 I2 equal to 0. Not 0. We have a constant term here. So this is 5. So equation number 3. So applying KVL to mesh 2. So let's start from here. So minus 2 Iy minus of I2 minus I1 minus 2 I2 minus 10 equal to 0. So what is Iy? I1, right? So I'll skip a step and directly write in terms of I1 and I2. So this is plus I1 minus 2 I1. So minus I1. So minus I1 minus 2 I2 equal to 10. So this is equation number 4. Right? So we have got both the equations. So solving simultaneously, we get I1 equal to I2 equal to. So I1 is what? Okay, so we have to solve that. So third equation is minus 10, 3, 5, minus 1, minus 2, 10. So I1 is, I'll take directly the positive sign 1.739 and I'll change the direction. I2 is again taking positive sign 4.13 ampere. Don't forget to write the unit. Right, so this is I1 and I2. But what they have asked, Ix and Iy. So what will be Ix? I1 minus I2, Iy will be I1. So that you solve for yourself. Okay. So this is the way you have to solve. Let's take one more sum. This will be a homework sum. I'll just give you the equations. You solve the rest yourself. So find the currents in the 3 meshes. So what is the first step? Assign mesh currents. I1, I2, I3. Find the currents in 3 meshes means you have to find I1, I2, I3 only. Next, assign polarities. So this will be plus minus, this will be plus minus. But if you observe, this is a current source, so we cannot apply KVL here. But what we can write, since mesh 3 has a current source, therefore I3 will be what directly? It is going in opposite direction, so minus 1 ampere. So this is equation number 1. Then you observe, we have to just find I1 and I2. We have found one of the mesh current. So what is the first step? Assign mesh currents, then assign polarities. Then what is the third step? To write the equations for dependent quantities. So this is the dependent quantity Ix. So this is the dependent quantity. You have to locate it where it is there. And where is Iy? Over here. So what will be Ix? Ix will be I1. What will be Iy? I2 in same direction as Iy minus I3. and I3 we know it is -1. Therefore Iy equal to what? I2 plus 1. So this is equation 2. This is equation 3. Right? So next what will we do? Applying KVL to mesh 1. Right? So what will we get? Let's start from here. So plus 5 minus I1 minus, it is a voltage source, so value is what? Iy. So minus Iy minus of I1 minus I2 equal to 0. Next what you have to do? Substitute Iy, because you will get two equations. Remember there are three meshes, so three equations you should get, but one you have directly got the answer because this is a current source. So remaining are two meshes, so you require two equations. So two equations you should get two unknowns, but you are getting three unknowns. So whenever you find this problem that we are having more than one variable, what you have to do? You have to write that extra variable in terms of I1 and I2. So what is Iy? I2 plus 1. So if you substitute this as I2 plus 1, what will happen? You will get one equation. So that will be equation number 4. We have already got 1, 2, 3. So then what you do? Apply KVL to mesh 2. So what is mesh 2? This thing. So what will you get? Minus of I2 minus I1 plus Iy. We are going from downwards to upwards. So minus 2 plus rise in potential. Minus I1 minus Ix minus of I2 minus I3. I2 minus I3 equal to 0. So what is the dependent variable? This. So Ix. What is Ix? I1. Do we have Iy here? We have Iy also. Iy is what? I2 plus 1. So substitute, solve, you will get equation number 5. So solving 4 and 5. We get. So we'll get what? I1 equal to I2 equal to. This will be your final answer. Okay. So make sure you solve this sum. Practice is very essential. All the mistakes are done while solving only. So make sure you solve this sum. Thank you.